Hello, everyone. I hope you are having a wonderful day here. Great, thank you very much. I see masks in the audience. That is appreciated. I'm immunocompromised. I really appreciate the chance to be able to do this safely, so let's try to keep me COVID-free. 2.5 years running, so I'm hoping not break that streak, fingers crossed. So the fundamental thing that I want to discuss today is how we manage complexity in our production environments. That we're facing environments that are increasingly complex, and we are not doing it because we like to spite ourselves. We're doing it because we want to accelerate delivery, because we want to make services that are better and that we can manage successfully. So cloud-native technology is both a curse and a blessing. It's a blessing because it enables us to get teams to deliver software independently. It enables us to really think about how do we decouple each microservice from each other microservice. But there's a catch. The catch is that we can't necessarily decouple these things without introducing seams. And the seams between the various pieces of technology, that's where the interesting stuff happens. So this complexity that we're adding is aiming to scale up our systems, to enable our developers, but yet it means that we can no longer fit everything inside of our head, that we can no longer understand or tame what's going on inside of our production systems. So how do we manage to juggle all of these constraints to deliver features and deliver higher reliability and scalability, and then doing break fix when things do not go according to plan? One thing that I know for certain is that we cannot do this via heroism. That once upon a time, you might have a lead developer like myself, and you would just go ahead and escalate to them all the time. But that does not work anymore. Number one, because we deserve vacations too. But secondly, that even a lead developer like myself, we can't necessarily debug everything just from memorizing it. So this is the background that I come from. As was mentioned, I've spent the past almost 2 decades of my life building and running large systems. And I am here to persuade you that there is a better approach than heroism, that there are instead more sustainable approaches that we can take to operating cloud-native systems at scale. So we need to have different strategies in order to deliver on production excellence. So one thing that people love to do, and certainly, sorry to my fellow vendors whom I'm insulting a little bit here, but like, you've heard a number of things today that are essentially that boil down to, if you just buy this one additional piece of technology, it will magically solve your problems. And unfortunately, that's a half-truth. That buying DevOps in a box does not work. Because when thinking about the original premise I had, right, of adding complexity, when you buy another tool, you are adding more complexity. You're adding more to this alphabet soup. And there are all kinds of fun and hilarious things that happen, and unexpected combinations. For instance, infrastructure as code. You may have heard about it last night, right? Like that Terraform is great and it solves all your problems. Well, solves all of your problems until you accidentally, instead of rm-rfing / on one machine, what happens if you accidentally delete all of your AWS environment, huh? Or things like writing more tests. Let's add more tests and more tests and more tests. But now the build is red, and it's flaky, and now people just press merge anyway, even if the build is red. But the number one thing that I see people advocate for is saying, you know, production ownership is sufficient to solve all of these problems. If you just put all of your developers on call with PagerDuty, that it magically solves everything, right? Feedback loops. And I think that's a half-truth again. That there is an element to having kind of responsibility for the systems that you develop, but you have to couple that with being able to manage those systems. That if you just have alerts going off over and over and over again, people are going to burn out. People are going to leave your organization because they are tired of getting paged at all hours and not being empowered to do anything about the problem. So one answer to this might be to, you know, why don't we reduce time to resolve, right? Like, why don't we just have a dashboard for everything? Unfortunately, the reality is that dashboards are a form of technical debt. They show you what happened in your last 20 outages, but what happened in your last 20 outages is not necessarily going to be what's going to solve your next outage. That the more we have to manage this cognitive burden of thinking about all this information and synthesizing it, the larger of a problem that we have. We're kind of digging ourselves this additional hole. So when we think about how to reduce time to recovery, it boils down to slightly different things. It boils down to how can we reduce the complexity and manage it and figure out what's happening. And yes, you can ring me up on the phone, and I might be able to solve your problem, but I might not. But I think it's a lot better to think about how do we solve these seams of the system? How do we improve the predictability of our systems? So this state of being perpetually burnt out, of getting paged all the time, of having incident after incident after incident, this is something that's called operational overload, where you have no time to do projects, and even when you do find an hour or two during your on-call shift, and you're like, I'm not getting paged right now, I have no tickets, how do we improve things? Oftentimes, organizations have no plan for how they improve their production sustainability. So how do we solve burnout and operational overload? The answer is we need to go back to our first principles and think about who actually operates the systems. We do. We, as individual engineers, are the people who operate the systems, and you cannot run a system out of burnt-out engineers. And tooling does not magically solve burnout. Tooling instead can help you with automating common patterns that you already know about, but it's not necessarily going to magically resolve 99% of your incidents. So tooling is complementary to our culture, but we need to focus first on that people, culture, and process. So this is where production excellence comes in. It's 4 things that I encourage you to do that will improve your life as a developer and as an operator of a complex cloud-native system. So our goal is not just to deliver increased reliability. Our goal is also to make our systems friendlier for the people who operate them. So the 4 elements. First of all, we have to know when are our systems too broken. Secondly, we have to be able to debug those systems and actually figure out what's going on so that we can repair the service. Third, we have to be able to collaborate across multiple teams in order to make that happen. And fourth and finally, we need to close that feedback loop. We need to eliminate any unnecessary complexity. So why did I say no when our systems are too broken? Why did I not say no when our systems are broken at all, right? And the answer is that our systems are always failing in small degrees. And we need to instead think about measuring when they violate that threshold of being too broken, where users are noticing the impairment. You don't necessarily care if the lawn is 100% green. If 100% of the blades of grass in the lawn are green, you care about whether it's green enough for your dog and your kids to play on it. So let's think about what this means in the context of our software systems. What we need is service-level indicators, which are a concept from site reliability engineering. And what service-level indicators enable us to do is they enable us to get on the same page about what it means for our reliability to meet our users' requirements, for our latency to meet our users' requirements. So we need to think about what are the critical user journeys that our users are trying to accomplish with our system, and then how do we actually ensure that those users' requirements are met. So we need to think about, is a given user transaction satisfactory or not? And this is often a product management concern as much as it is a operator or an engineer concern. So let's think about that, right? Like, how do we know whether our customers are happy? And if you're not sure, one way is to try it out on yourself, right? Slow down your system or have it throw errors. When does it start to feel sluggish? When do you start to feel disgruntled? Here's a real story. I was out at lunch yesterday, and I was with a friend, and we were trying to order from Mr. Yum. Sorry if there's anyone from Mr. Yum here in the audience. And I tried tapping on the button to order an item, and sat there and spun for 10 seconds. That was not a happy user experience. I was looking forward to consuming some really great New Zealand steak, and I could not. So at the end of the day, we're trying to bucket events into a good or bad user experience. For instance, maybe it should be that you get a successful response in less than 250 milliseconds. And after that, we can figure out what's the ratio of good transactions over the total number of transactions. So that starts to get at the idea of measuring reliability. And that lets us set a target service level objective, which is an aggregation across multiple service level indicators. So we want to measure that over a longer window of time. For instance, it might be OK to be down for a minute or two, but it's probably not OK to be down for an entire day and then say, oh, but we were down yesterday, but we're not down today, so we're 100% up today, right? Like, we have to think in terms of the memories of our users as well as the timing of our sprints and how we think about managing the software delivery lifecycle. So for instance, I might say that I'm aiming to deliver 99.9% of transactions good in the past 30 days. Why not 100%? Well, the answer is that each 9 costs an exponentially increasing amount of money. Sure, I could deliver a service that was 99.99999% reliable if you let me launch satellites into space and give everyone custom satellite phones, right? Like, sure. But otherwise, you're spending money chasing reliability that your customers will never notice. So what do we do once we have this concept of acceptable reliability and acceptable thresholds? The first thing is that we can cut down on the amount of alert fatigue. Instead of getting alerted every single time that, disk is 90.01% full, 90.01% full, that's an emergency, right? No, it's not. Are users' transactions impacted too much? And if not, it's not an emergency. So we can think in terms of the amount of allowed and availability. If my service has a requirement to be 99.9% up, that means that 1.1% of transactions are allowed to fail. So if I'm serving 1 million transactions per month, 1,000 transactions per month are allowed to fail. So I'm serving 100 bad transactions per hour. I'm going to run through my budget in 10 hours. So yes, please wake me up for that. If I'm just having 2 bad transactions per hour, that's going to take hundreds of hours to deplete, right? So I don't need to get woken up. At worst, I can get alerted during business hours and take care of it the next business day. The second thing that SLOs empower us to do is they empower us to decide whether we're innovating or whether we're focusing on reliability at any given moment. If I have lots of leftover error budget, I can think about using feature flags to do an experiment on a small subset of users, because in the worst case, I serve errors to those users for 5 minutes, and then I roll back that experiment that only impacted 2% of my users. Conversely, if I've had a lot of really bad outages recently, I can instead think about having the argument that no additional feature I deliver is going to be as impactful as increasing reliability, because customers have to trust the reliability of my service to trust any feature that I might deliver. So measure what you can, and then think about iterating it over time. So things like your load balancer logs are sufficient to get at least a first pass at what's important to your customers. But this is only half of the picture. The reason is that alerting is only half of delivering reliability. What matters as well is what happens after that alert goes off. Because our outages are never exactly identical. Because if you could have predicted what the bug was going to be in the first place, you never would have written the bug, right? None of us are maliciously committing code into production. Well, if you are, I'll talk to you afterwards. But you cannot predict failure modes in advance, so you have to be able to debug new things that you've never seen before in production. We have to be able to go through this feedback loop in our head of what do I think is going wrong, how can I verify whether that's the case, and then how do I fix it? So the faster you're able to form and test hypotheses, the easier of a time you're going to have with resolving your outages. And we have to be able to ask new questions. Not just, what do the last 10 graphs, what do the last kind of 10 things that I plotted have to do with this, but instead to be able to combine dimensions in new ways. All this is to say that our services have to be observable. We have to be able to debug our systems and ask any question of our systems and investigate unknown situations, just using the telemetry that's emitted from those systems and not anything else. We shouldn't have to push new code in order to understand what's going on in the middle of an outage. So we need to be able to examine those events in context to really understand what's happening, why are things happening, what called what in order to cause that crash to happen. And can we explain the variance? Can we understand what separates a successful transaction from an unsuccessful transaction? And have the relevant dimensions at our fingertips to be able to understand why is this happening and how do I fix it? Even better yet, why do I have to sit there and watch it happen? Why can I not automatically roll back the bad release and then be able to look at it with a cup of coffee in hand in the morning? So observability is used in break fix, for sure, but it's also something that goes beyond that. We can use it throughout the entire software development lifecycle in order to speed up our builds or speed up our unit tests or more. The other misconception I want to talk about, though, is that, unfortunately, people conflate the signal types that can be used in observability with the actual observability capability itself. I'll tell you this. I can collect all the logs, traces, and metrics in the world. If I route them to dev null, You're not going to be able to answer any questions. But yet, you'll have logs, traces, and metrics, right? So we have to be able to actually practically use the telemetry data that we have in order to answer the questions that we have about our system. Otherwise, we don't have observability. We just have Pokemon trading cards. So SLOs and observability go together because SLOs tell you when things are too broken, but observability really helps you actually debug, to really investigate and solve those issues when they do come up. But we also have to consider the entire human picture as well. That without collaboration, without psychological safety, we do not have functioning teams that are able to effectively resolve incidents. We cannot rely on individual developers, as I said earlier, to be able to understand everything, so we have to work across multiple different teams. Because when we're in this cloud-native microservices environment, a team that's 5 layers downstream of you can push a change that breaks you. So how do you thread that together? How do you get to the point where you can investigate and figure out what's happening without pointing fingers at each other, without disagreeing about the data, but instead being able to follow the trail of breadcrumbs and mitigate and fix? And this is not just something that happens within our own companies. This happens across multiple different functions and even ranging down to your cloud provider. So we should be doing game days. We should be doing disaster drills. We should be rehearsing what's going to happen at 3 a.m. at 3 p.m. so that we can find these issues out when people are not grumpy and tired and at their worst. We need to also think about how are we propagating knowledge. Do we have a culture where people are saying, you know, I can't believe you didn't know that? Or are we actually saying, you know what, thank you for asking the question. I'm sorry it wasn't documented well enough. Let's write that down. Let's make sure that the next person doesn't have to ask that question. One key area that I see friction is if people are not on the same page with using the same telemetry sources and the same telemetry tools. That if your data is scattered across 5 different systems, those 5 systems will be in disagreement. What we actually care about is measuring the user experience and debugging it as effectively as possible. And this often means, even though outages are not exactly the same, there are common patterns that you can observe. So learn from the past, because one day you are going to be that person who looks at a piece of code and is like, who's the numbskull who wrote that? Wait, it was me. I wrote that 5 years ago, right? So let's think about how to resolve common outage patterns and to learn from our experience as engineers. When we do risk analysis can really help us figure out what the most important thing to work on is that will improve the reliability of our system. Let's suppose that the Sydney Harbor Bridge has cars falling through the roadbed, and yes, the next big earthquake and the tsunami is coming in the next 20 to 30 years, and it needs a fresh coat of paint. Which one of those 3 things do you think we should work on? I think we should probably work on the fact that the cars are falling through the roadbed, right? So in general, what we care about is how often does a risk happen, and how bad is it when it does happen? And that can influence our prioritization. Here's a hint, though. When I say the words, the MySQL server, how many of you get a shudder down your spine when you hear the words, the MySQL server? Right? The MySQL server is going to go down at least once a year. You know that for a fact. But what you can control is how bad it is. Right? You can say, the MySQL server going down, we can make that a hot standby. Right? We can have a failover that takes 5 seconds, not 3 hours to replay from the tapes. Or we can have not just 1 MySQL server, but maybe we can have 5 MySQL servers or 50 MySQL servers, so any individual outage only takes out a small percentage of our users. These are things that enable us to address the most significant risks and to reduce them. How do we know which risks are the most significant? Well, the answer is we just talked about this idea of critical user journeys. We talked about the idea about measuring reliability. So what you want to do is you want to address the risks that impinge your ability to solve your SLO, to meet your SLO. Right? If I'm allowed to serve 1,000 bad requests per month, and 1 failure mode is contributing to 500 potential bad failures per month, I'd better fix that, right? That's half of my error budget right there. And that doesn't even account for the unknown unknowns. That just accounts for a risk that I already know about. So that's your business case, right? That is your business case for being able to proactively plan and address systematic issues that might impair your reliability. But there is one key element that I think is important to talk about. What happens if it takes you 2 hours of stumbling around in the dark every single time you have an incident in order to figure out even where are you, what's going on? The answer is that that really impairs your time to resolve, which results in a lot of dropped user queries. That results in a lot of late nights. And that might not be a singular root cause, but a lack of observability really impairs your ability to deliver high-quality software and to keep it running in production. So in order to address a systematic risk, we have to add the right degree of instrumentation. We have to make sure that we're collecting that data somewhere that can actually answer our questions. Another key area to focus on is collaboration. That if your team is disjointed, if you're not practicing chat ops, if you're not rehearsing your incidents, if you're pointing fingers and saying that's a problem between keyboard and chair, that means people are not going to raise their hand and say, hey, I think it was my problem, right? Like, hey, I think I broke the build. Or hey, fun story. When there was the large Google Cloud incident in 2018 in June, what happened was that the way it was resolved in less than half an hour is the developer who had pushed the commit that broke Google Cloud for half an hour, they raised their hand and said, I broke it, I'm rolling it back, it'll already be fixed in 20 minutes. They weren't hiding, saying, like, I'm going to try to hide and cover up that I did it because I'm afraid of being fired, right? Like, they volunteered, and that made everything go a lot smoother. So really make sure that people feel psychologically safe, as Damien encouraged you to do. You don't have to be a hero to operate a cloud-native system at scale. You just have to ensure that you're embracing the right cultural practices, and yes, that you have the right set of tools. So as someone who is an engineer at Honeycomb, I think a lot about these ideas of velocity, reliability, and scalability, and living those values every day. We're a team of about 40 engineers, and we're able to deploy every single day out of the year with confidence. We're delivering on average about 10 builds every single day. We push every hour on the hour. And yet, we don't, in general, have weekend fire drills. And we've also managed this while our traffic has gone up by a factor of 3. Every single year for the past 3 years, our traffic has roughly tripled. So this is what that looks like, right? Our read load has tripled, our write load has tripled, and yet we've handled it. How? I don't think it's because, we hire the smartest people in the world. I don't think it's because we have the best tools in the world. I think it's because we've really embraced this idea of production excellence, of keeping our SLOs, of investing in telemetry and observability, of collaborating with each other and being proactive about our risks. If you're interested in learning more about some of these concepts, and especially about observability, I encourage you to check out my book called Observability Engineering, which you can get a free copy of if you go and view the link on screen. See people with cameras out, so I'll go ahead and keep that up for a second. But this is something that I think is really important to delivering high-quality software, is really in the same way that we wouldn't think about checking in code without tests or checking in code without comments, we should not be checking in code without a plan for how we're going to observe it. And this book will show you how. So in summary, production excellence, and yes, a tool like Honeycomb, but also many of our competitors do this too, can really help you with measuring and knowing when are things too broken, and helping you really understand how do you fix those unknown unknowns. And then it's up to you to collaborate across your teams and proactively invest in fixing those underlying issues. Thank you very much, and I think I've got like a minute and a half to take any questions, so maybe I'll take 1 or 2 questions.